Hello, it's Rick here. So it's 12:05 p.m. on January the 7th, 2013. Second day of me um, reading off some stuff. Here's an interesting little topic, or subject, topic, whatever. Nanotechnology pushes battery life to eternity. In a crucial step forward, the development of self-powering portable electronics, researchers at RMIT University in Melbourne have for the first time characterized the ability of piezoelectric thin films to turn mechanical pressure into electricity. The pioneering result is published in the 21st June issue of the leading materials science journal, Advanced Functional Materials. Lead co-author Dr. Madhu Bhaskaran. Again, I butcher names, so I apologize. And I butcher words, but yep, I'll get better through time. Dr. Madhu said the research combined the potential of piezoelectric electrics material capable of converting pressure into electrical energy, and the cornerstone of microchip manufacturing, thin film technology. The power of piezoelectrics could be integrated into running shoes to charge mobile phones, enable laptops to be powered through typing, or even used to convert blood pressure into a power source for pacemakers, essentially creating an everlasting battery, she said. The concept of energy harvesting using piezoelectric nanomaterials has been demonstrated, but the realization of these structures can be complex and they are poorly suited to mass fabrication. Our study focused on thin film coatings because we believe they hold the only practical possibility of integrating piezoelectrics into existing electronic technology. The Australian Research Council funded study assessed the energy generation capabilities of piezoelectric thin films at the nanoscale, for the first time precisely measuring the level of electrical voltage and current, and therefore power, that could be generated. Dr. Madhu co-authored the study with Dr. Sarath Sriram within RMIT's Microplatforms Research Group, led by Professor Arnan Mitchell. The pair collaborated with Australian National University's Dr. Simon Ruffle on the research. With a drive for alternative energy solutions, we need to find more efficient ways to power microchips, which are the building blocks of everyday technology like the smarter phone or faster computer, Dr. Madhu said. The next key challenge will be amplifying the electrical energy generated by piezoelectric materials to enable them to be integrated into low-cost compact structures. Sounds interesting. Thoughts, ideas, anything on this topic it's pretty interesting. I like nanoparticles and like the nano side of technology and other aspects of life, because at the same time I'm also a macro kind of person. I see bigger pictures, but I'll go on to one more. I'm not exactly sure which one I want to read, but it was on phys.org. I'll post a link to the bottom below. But this next one will be from sciencenews.org. I don't really read science, so whatever catches my attention, I'll be reading more on that as well. So if anybody has any good reads as well, feel free to pass it along so I can better my social skills as well, at least my talking skill, because that's the one thing I feel very insecure about. Which one? They're all rather interesting. But then at the same time, I think this one will get better. Will help further along one of my ideas I would love to see happen for like light speed or self-gravitational vehicles, which is hottest temperatures ever measured is a -1. Alright, hottest temperature ever measured is a -1. Ultra cold gas sets record on the Kelvin scale by Andrew Grant. Coaxing a gas to a negative number on the Kelvin scale has produced, paradoxically, the hottest temperature ever measured. The study published in the January 4th Science will help physicists learn about quantum phenomena, and perhaps even the strange form of energy that dominates the universe. A negative Kelvin temperature indicates that particles at high energies outnumber those at low energies. We are used to positive temperatures, says Achim Rosch, a physicist at the University of Cologne. Is that how you spell it? Cologne. I'll also post this in the link below. In Germany, who was not involved in the research. But there's nothing forbidden about negative temperatures. It's always fascinating to do something unusual. Temperature is commonly interpreted as a measure of the average energy of the particles in a sample. Each of the molecules buzzing around in a pot of boiling water, for example, has more energy on average than a sluggish water molecule within an ice cube. But for scientists who study matter in quantum scales, temperature is better defined as the energy distribution of the particles in a sample, just above absolute zero, 0 Kelvin, or -273 Celsius. Almost all of the particles within a sample have energies very close to zero, with little variations. But as temperatures rise, the variation in energies widens. Some particles still have very small energies, but others have more. Physicist Ulrich Schneider at the Ludwig Maximilians University of Munich set out to do something unusual. He wanted to cajole the particles within a substance to be confined to a very high amount of energy. In other words, instead of having the particles start at a minimum energy, corresponding to absolute zero, and spreading out towards higher energies, he wanted to start at a maximum energy and spread toward lower energies. By definition, such a substance would have a negative Kelvin temperature. His team achieved that with potassium atoms chilled to a few billionths Kelvin above absolute zero. Through the use of lasers and magnets, the team managed to get the atoms to jump to a high energy state. By creating a cluster of particles exclusively at high energies, Schneider and his colleagues had a gas at a few billionths negative Kelvin. This temperature is technically not below absolute zero. Because negative on the Kelvin scale, unlike that on Fahrenheit or Celsius scale, is a construct that simply indicates something about the energy state of the particles involved. In fact, the new creation is extremely hot because of the high energies of the particles. Heat travels from hot to cold, Schneider says, and heat will always flow away from this gas. It's actually hotter than everything we know, he says. Despite the semantics involved, this experiment isn't merely a fun physics trick. Scientists are fascinated by negative temperature substances because they have other strange properties. The molecules in a typical gas spread out and exert a force on the walls of their container. But a negative temperature gas also has negative pressure, meaning the particles tend to cave in rather than expand. It wants to collapse into a single point, Schneider says. Singularity. Oh! Negative pressure may be important in another part of the physics universe. Cosmologists believe that dark energy, the mysterious entity that is causing the universe to expand at an accelerating rate, also has negative pressure. Snyder suggests that experimenting with the quantum phenomenon of negative temperatures could reveal the nature of dark energy throughout the cosmos. Those were two interesting articles: nanotechnology and, of course, hottest temperature ever measured absolute is below the absolute zero line. So it pretty much starts coming like from circle, like full circle from kind of spiritual, religion, science, like pretty much the triangle. I'm trying to think which one would it be. What on top right now would be what the spiritual religion, right? Um, and then at one of the other scales, one of the other points would be science, and I completely forgot what I just said about the spiritual religion, science, and what was the other one? Technology? Would you say technology? But technology would be considered science as well. What's the third factor? Philosophy? No, that would be religion too, because religion is actually diverse from philosophy, and then philosophy came from, I think, one other thing, and then from there it was an actual process of knowing and doing, and it has been done since like the ancient Egyptians on back. And by ancient Egyptians, I'm speaking of uh, the ones that actually created the pyramids and all that, which that in itself kind of make me feel as if that could have been the Atlanteans, like at least part of the Atlanteans. But yet, I would love to try to figure out more of the history of the Earth at that time when Atlantis was around, and then like at those times what was happening. And I'm not sure. I don't personally have no remembrance of it, but it's a good topic to speak about. However, it doesn't help. Well, it might help us further along ourselves, because it seems like everyone's doesn't understand, like, what the fuck. Like, our past is really unknown for the most part. At the same time, we're here and now. Oh well, I love you guys. Peace.